All right, so today we are talking about functions. So we're going to call this the introduction to functions. And all a function is you guys know what functions are because we've been using them for a long time. Let's just say I had whatever y equals 3x plus 2. I'm just making that up. Okay. Well, the problem is that if I have multiple things like y equals 3x plus 2, but I've got another line, y equals negative 2x minus 7, and one more, y equals x minus 2. Those are three lines. And it can be awfully confusing. Which one am I talking about? Oh, this line here, or this line here, this line here. And so what we do is we have a new thing called function notation, where essentially the y part gets turned into this function notation. So this one over here, I'm going to call, well, I'll do this one right here. This one right here, I'll call f of x. You just use f of x. This is f of x equals negative 2x minus 7. And then this one, instead of f of x, I could call it g of x. And this one would be x minus 2. And whatever this one up here could be h of x. H of x equals 3x plus 2. And now it's really easy for me to be able to say right here, if I say, oh, this is the top function, or this is the first one I wrote, or this is 3x plus 2. It's hard to describe what it is. But here I just say, oh no, I'm talking about h of x. Versus this one, I'm talking about f of x, versus this one I'm talking about g of x. So it just makes our life easier. If we have multiple different equations that we're doing, function notation allows us an easy way to describe each one of them. This is f, this is g, this is h, this is q, this is l, this is whatever. You just have a different letter for each one, and so it makes it easy to deal with. But the equation is exactly the same. This thing here and this thing here are saying the exact same thing. We would graph them the same, we would solve them the same, everything is exactly the same. We're just changing the notation so it's easy to tell the difference between the different kinds, in this case f, g, and h. Okay, that's function notation. Now let's talk about, well, what is a function? Okay. And a function is just a box. Okay, and what goes in the box is what the equation is. So we can do this one right here, x minus 2. Okay, so I put something in the box, in this case x. I put something in the box, that's called an input. And then something comes out of the box, and that's a y, which is called an output. So all this function is it's x minus 2. So if I put in an input, let's say I put in 5 into the box, then what comes out? Well, 5 minus 2 is 3. A function is just a box where when I put something in, something comes out. But the key thing, it's key, so I'll put it in red here, is that for each x I put into my box, for each x, I get one and only one. One and only one output, or y. If I put in an x and I don't get an output, or I put in an x and I get more than one output, then it's not a function. I have to, for every x I put in, I get a unique output out. I get one and only one output out. So a function, you can show a function in multiple different ways. You can show a function with a table. Okay, and we'll continue to do the one x minus 2. So if I put in, as I said, I put in, here's my x, here's my y. So I put in 5, I get out 5 minus 2 is 3. If I put in 4, 4 minus 2 is 2. If I put in 3, I get a 1. If I put in a 0, I get a negative 2. This is a table, and this is one way of showing the inputs and outputs. There's the inputs right there, the x's, and there's the outputs right there, the y's, of a function. A table is one way to do it. Another way to do it is what's called a map. Okay? And a map, instead of showing x's and y's, we call it domain and range, which we'll talk about later. But essentially, the domains are the x's and the range of the y's. And then I can put in the same information. So this is a 5, this is a 3, this is a 4, this is a 2, this is a 3, this is a 1, this is a 0, and this is a negative 2. The only difference is that a map shows me, here are all my domains. I'm going to put a little circle around these, and here are all my ranges. And the only difference is that a map uses arrows to show it. So 5 becomes 3, 4 becomes 2, 3 becomes 1, and 0 becomes negative 2. But this right here is showing the exact same information as the table. The final way we can show this same information is with a graph. So if I have a graph, right, well, I've got the point 5,3. So that point there, I've got the point 4,2, that's that point there. I've got that point 3,1, that's the point there. And I've got the point 0, negative 2, that's that point there. So these are all showing the exact same information. This is showing 5,3, this is showing 4,2, this is showing 3,1, this is showing 0, negative 2. The exact same thing I had in my table, the exact same thing I have in my map, I can also show on my graph. These are all the same, showing the same information, just 3 different ways. The next thing I want to talk about is what's called discrete information versus continuous. Continuous. Okay. So all the things I've shown so far here are discrete. When I put in a 5, I get a 3. When I put in a 4, I get a 2. There's a finite number of inputs. Discrete is a finite number of inputs. Sorry, I'm running out of space, so let's just say finite number. Finite number of inputs. Okay, that's discrete. Continuous is an infinite number of inputs. So if I had the function x minus 2, or this one like here, g of x equals x minus 2, well, I've graphed it over here only for the points 5, 4, 3, and 0. That's what makes it discrete, because I have a finite number of inputs. I have only 4. If I wanted to make it a continuous function, that is to show an infinite number of points, I could show this line, right? I could say, okay, well, actually, the output of f of g of x minus 2, it actually looks like this. It's a line, and it goes forever in both directions, there and there. So this is continuous input, because there's actually an infinite number of inputs. It's not just 5 and 4, but 5 and 4.9 and 4.8 and 4.887 and everything in between, every single point between. Okay, so this is a continuous input the way I've drawn it here, or I could even draw it like this, like that, with dots on the end to show that so this one would be all the points between all the inputs of 0 to 5, all the points between, but that would still be continuous because it's an infinite number. Okay, so you can think of it kind of like this: discrete are whole numbers. So if I said a function that tells me how many students I have in class, well, that would be a discrete function because the answer is always going to be a whole number. I might have 7 students in class, or 15, or 22, but I'm never going to have 22.4. I'm never going to have 22.7765. But if I said, hey, how much gas can I put in my car? Well, that would be a continuous function, because even if my car only held 10 gallons, I could put in 8 gallons, or 9, or 10, or 8.5, or 8.6, or 8.7, or 8.72. So it would be all the points in between. So again, a function that would show me like the number of students in a class, how many steps did I walk up in the stairwell, whatever. Those would be discrete. Continuous would be things like how much gas is in my car, or which distance did I run, because I can run 5 miles, or I can run 5.01, or 5.02, or all the points in between, so that would be continuous. Okay, so remember that I said for a function, each input, or I should say for each input, sorry, let's try that again. For each input, that's an x, there is one and only one output. Output, which is a y. So, how do you tell if something is a function or not? Well, if I have a table, here's an example again, here's a table. Here's x, here's y. And if I said if x is 0, y is 1, for x is 1, y is 2, for x is 2, y is 3. Okay, this is a function because for every x there is one and only one y. So this one, yep, that's a function. But for this one over here, if I say x is 0, y is 1, x is 1, y is 2, and x is 1, y is 3, okay, this table is not a function. Why? Because sometimes when I put in 1, I get 2. Sometimes when I put in 1, I get 3. No, that's not a function, so that wouldn't work. Okay? We can show this same information on a map. Right? Here's map 1, where I've got 0 goes to 1, 1 goes to 2, and 2 goes to 3. Okay, once again, so that's the same information. Yep, that's a function. But if I take that same information and make a map of it over here, I've got my 0 goes to 1, and 1 goes to both 2 and 3. So no, this is not a function because of right here. 1 and 2, 1 goes to 2 and 3. There's more than one output. And then finally, on a graph, I'll do the two graphs over here. Here's graph 1. Where I've got 0, 1, 1, 2, and 2, 3. This one is a function, and if I do graph 2, I'll do the same thing here. I've got 0, 1, 0, 1, 1, 2, and 1, 3. This one is a function because it passes what's called the vertical line test. What the vertical line test says is if I take a vertical line like my pencil or something and make it a vertical line, there's no vertical line that I can draw that goes through more than one point. So this line here, it only goes through one. This line here, it only goes through one. This line here, it only goes through one. But this one over here, when I draw this vertical line right here, it goes through 1, 2 points. So this one would not be a function because it fails the vertical line test. This one here is a function because it passes the vertical line test. Functions is how to evaluate functions. And so, in evaluating functions, if I go back to that function I had before, f of x equals x minus 2, you guys know what to do, how to do this. This is the equivalent of just y equals x minus 2. And so if I said, hey, evaluate the function f of x, x minus 2, you could do it and I said, hey, graph this function. Okay, well, you can graph it. We've got y equals mx plus b. Our b is negative 2. That's down here, 1, 2. Our slope would just be 1. So up, rise 1, run 1, rise 1, run 1. There's my line right there. Or I could say evaluate f of x equals x minus 2 for value x equals 2. And the notation I would use is, instead of now saying f of x, I would just say f of 2. And that would equal, I'm going to rewrite this equation right here, but every time I see an x, I'm going to put in a 2. So that would just be equal to 2 minus 2, which equals 0. Well, what's f of 3? That would be equal to 3 minus 2, which equals 1. So that's how you just evaluate the function. The notation is, I have here f of x equals x minus 2. So if I want to know what if x equals 2, I just put in a 2 here and a 2 there. Or if I just wanted to graph it like I have in the past, if I have f of x equals x minus 2, show me all the solutions with a graph. Well, that's just the same thing as y equals x minus 2, which we graphed right